Hello and a warm welcome back. Today on the bench is a valve tester, DIY valve tester, and in a nutshell I've got to make this work with that, and to do that we need something like this. This is just a rough sort of diagram that I worked out. So we need a switch to assign either anode 1 or anode 2, because this is a sort of dual anode tester. I designed that in the last iteration of this thing. Then we've got a 100R sense resistor that goes with a Felpham PCB. I want to be able to shunt that out with a switch, which I'm going to fit next. Why? As you saw, I was testing a 6528 beefy triode, which is designed as a regulation valve, meaning that they have very low anode resistance. So you don't want anything like a 100 ohm sense resistor interfering with that emission testing of valves like that. So it needs to be shuntable out. And then essentially they just go to J1 on the Felpham PCB, and the HT comes in here. It's a little bit more complicated in that I've already got like a method of testing anode current, and that's just by putting a couple of Fluke 25s in there configured as ammeters, and that's how I test anode current. So yeah, but I think we can make it work without that. Without those connected we can test GM. What else? I was thinking of fitting try and get all this in. Let's take the top one first. I was thinking of fitting a way to monitor gas, you know, like if a valve is gassy. Here's our 100R, and essentially all we'd need is a 10 meg resistor, and we just have to switch out the sort of GM testing function, which is another switch, and then you basically connect a 10 meg resistor between the bias, negative bias supply and the control grid of the valve under test. And if the valve is gassy, then it's going to start to draw grid current. Any grid current going through will go through this 10 meg resistor here and obviously cause a voltage drop. You can use that voltage drop into J1 to read off like a current testing. I'm not sure whether to put that one in. And then another sort of function we could put on is a cathode heater short sort of test. And again, we just use a 10 meg resistor from the heater, one side of the heater, to ground. Well, you know, again, I could do that. However, all this adds more switches, more complication. And I know from using simple supplies like this one in the past that if a valve is iffy, and you don't get many of them, to be honest, I must have tested thousands of valves on a simple setup emission tester like this, and I know by the way that the power supplies and the meters etc are reacting whether a valve is gassy or it's got a short or not. I can just tell, so I don't really need to add all that. And then there was another one I was thinking of adding, which was a sort of anode other electrode sort of short function. Again, that's adding far more that's me, you know, it's more switching, more wiring, more complication, and I don't need it. Again, if a valve has got something wrong with it like that, I tend to know basically, because like the meters won't react like they ordinarily react, and if it, you know, something like that does happen, then this is protected, it's fused and all the rest of it. So yeah, no worries. So I was thinking of doing that, not gonna bother. keep it simple, KISS as they say. Right, I'll continue on fettling this, and then next we'll have a look at testing the Felpham supply. Here we are some time later. The power supply is secured on standoffs in the valve tester. If I drop you down, as you can see, I've tidied all the wiring up in the valve tester by lacing all the wires, you know, the wiring harness together. That's really good. The only problem is it might be a little bit stiff, you know, when we're going up and down sort of thing. Yeah, that looked like I was shagging the camera there, but I wasn't. Anyway, I digress. So that's all cushy. So power supply's in there. There's the board on standoffs that it will go in there. Needed to be quite high sort of standoffs and these big silly bolts, because the only standoffs I had was to cut an old tent pole down, and it's just got like a really big hole in the centre. It's, you know, needing these big daft bolts. So the first thing I did was turned on the valve tester's power supply, and then I went over, obviously, to make sure that I got plus 15 minus 15 volts on J8, which is your power supply input. And then I went on every single op amp to check that I also had plus 15 minus 15 volts on pins 4 and 8 of all the TL072s, and I can't remember the exact pin. I think it's pin 4 and 7 on the, which is U2, which is a TL071. As mentioned previously, I'm not really using a lot of this functionality, because I'm only intending to use this as a sort of GM testing board. So all the anode current, anode voltage, screen grid voltage and all the rest of it I'm not really using, but for now I'm just going to leave it as is. We turn on, we apply power, short out J1, and basically I'm just doing that with a switch up there. And then on J6, which is here up the top, and our other meter, our black lead on the ground, we adjust RV3, this one, until we get 0 volts on the meter. Right, there we go, we've got the meter there. It was already at 0. I'm just going to adjust it again just to illustrate the point. So RV3 is over here, look, the left hand side of the board. We want 0 volts. So I'm going clockwise. I've gone too far. Yeah, the last bit is a bit fiddly. It doesn't help my trim pots being a bit wobbly. There, 0 volts. So that's the first process, that's the first bit of calibration. That minus thing there is obviously just going to pop on now and again, because it's, you know, saying that the meter is, it's sort of it's saying the null is moving basically, but that's fine. Right, next process. The next bit of calibration we need is to remove the short, put your 100 ohm sense resistor that you're going to use in the actual valve tester, put that across J1, and then we need to pass a 10 milliamp current through there, and to do that I'll use a power supply. I'm just using my bench power supply, a 10k precision 10 turn pot, and my meter obviously to give me about 1 volt at the moment. it's not connected up to the 100 ohm resistor. I'm going to adjust that when I connect it all up. So I've used the 10k pot. It can be 10k, 20k, it can be any sort of pot, or if you've got a bench meter that is really accurate, then you don't need the pot. I've just done that to give me a bit more resolution. So if we connect that, yeah, that's not working, is it? Oh no. Right, we've got 1 volt going across that 1 ohm resistor. Just crept up a bit more. Adding RX. Okay now. Yeah, this pot could have been, should have used a bigger pot. Right, that's fine, that'll do me. So now I need to move all this. That goes there, that goes on to, our meter goes there, that goes on to test point 1, which is J6 on the PCB, and it says we should have a reading of 1 volt. Yeah, 1 volt. We had 1.001, so everything's good there. I'm going to turn that up because I don't want to knacker that. No, actually it's okay. I didn't want to knacker up the 10 turn precision pot or the small 100 ohm resistor. Right, next bit of calibration. So I've got 0.1 volts or 100 millivolts ish on the meter there. That is connected to J2 here. We've got 100 volts going in here onto pin 2 of J1. That is indicated by a little arrow, but it's the bottom one of those 2 terminals there. And basically you bung in 100 volts, 200 volts or whatever into J1, and then you adjust RV1 here until you get a corresponding reading on your meter. Next we're going to do the same thing, obviously after having made sure that we haven't got a high voltage there. We're going to do the same thing on J3 for the screen grid voltage. So as mentioned, we move our HT from J2 to J3. As you can see here, this top pin here is ground, so it wants to be the bottom pin. I think that one's got an arrow on it as well, is it? Yeah, it has. The PCB legend has got a little arrow here telling you which, where to put your HT. And then we move our meter from J2 to J4. That is where I would presume you connect your meter to monitor screen grid voltage. And again, like I say, we apply 100 volts, and this time we adjust RV2. So let's bring it on. Just going to check I've got 100 volts still using the other meter. I've got 101.1 it's telling me, and so if we look at our meter, it's just reading a little bit low, so we just RV2 till that's reading 101 millivolts. I'm going the wrong way. There we go. So that's those 2 done. Like I say, I'm not going to use this functionality, but I thought I'd cover it for some of you that probably finding things a little bit tricky and not knowing what to do. I'm just going to turn this off. to make testing easy, I've just tacked on old cut off resistor leads, component leads, onto all the pins that I need to measure, you know, all the terminals that I need to measure to make life easier. I think some of you will probably use those little screw terminal things to make life easier. I ain't gonna bother with any of them. As you can see, I've got a smashing sine wave on the scope screen, absolutely beautiful, and it's measuring 0.492 millivolts RMS. Now then, as you see, I've made a modification to my board. Originally this had a pair of diodes there and a 33k feedback resistor to control the gain. However, I was only getting something like 210, sorry, just deal with this pigeon, fuck off. I was only getting 210 millivolts output from the oscillator from this U5 here. I tried everything. I tried replacing it with a NE5532 and an LM1494 or something like that. No go. So what I did, I used the circuit that I've used before and changed the circuit somewhat. So what I've used instead of, let me just make sure I've got me things right, I think that's R37, no, not R37. On the board it's a 5K6 and a 39K in parallel to give you 4K8, something like that. And then, like I say, R37, is it R37? Is a feedback resistor, is that right? What have we got there? That's a 10K, no, that's not right. No, it's here. R35 is a feedback resistor, I think was a 33K. So what I've done, I've replaced that 5K6 and 39K resistor for an automotive light bulb. These are 28 volts, about 400 milliamps, I think, something like that. If anybody's struggling on the forum, I've got plenty of these if anybody wants to try this. And then what I've done, I've replaced RV35 with a 500 ohm 10-turn preset. I had to drill the board a little bit to do that and sort of link it up underneath, but I'm getting a far better output. So in a nutshell, I need to reduce that until we get 430. I had a bit of a job with this last time. Right, I've gone up. Because I think this is, basically this can do a lot more than this. So maybe the feedback resistor, this 500R pot, there we go. I've got a sine wave back up now. I'll point you at the screen. So the thing is, with a lamp stabilized or light bulb stabilized wine bridge oscillator, is the very boingy when you're adjusting them and turning them on. See what I mean? It took me an hour last time to adjust this, so why it's suddenly gone up I don't know. See, we're up too much now. Now then, Peter in his instructions says that you should have 430 milliamps. I'm just going to leave that there because I could be here fucking hours and I've got shit to do. And then what he says, with 100 ohm resistor across J1, on J10 here, this thing here, which is the output straight out of U5, I think before the buffer. So it's basically straight out the output of U5, the oscillator. And then it says what to do is you get 100 ohm resistor, connect that to pin 2 of junction 1 or whatever you call it, and you should have 200 millivolts RMS. However, what happens is in this circuit you've got U5 here, U5A I think is the oscillator, U5B is a non-inverting buffer output. So surely you'd use the output from that, not the output straight out of the oscillator. So I don't understand what is going on about there. So basically I'm just going to play about until I've got it right. Right, I've just been talking to myself for about 10 minutes. Never mind, nothing new there then. Right, if we look at the scope, see we've got a lovely sine wave, and if we look at the meter, we've got 430 millivolts from our oscillator. Right then, I'll try and do this without any squeaking. There's a board. I have J10 here via a 100 ohm resistor, the oscillator output connected to one end of our 100 ohm sense resistor, the other end is going to ground, and we should read across that, should read 200 millivolts. One moment. So I'll point you at this meter. I'm just going to put that on there temporarily. We should read 200. Sorry. Right, it's reading 210. If I then move that probe, well, meter lead, over to J14, which is there, spin you back round, we have a reading of 204, and that equates to, according to the instructions that Peter wrote, a GM of 20 millivolts, sorry, 20 milliamps per volt. So in theory, and this is where I'm not sure what we do next, where do we connect the oscillator to? I'll just turn this off. So where are we? We've got U5 there, U5A and B. As mentioned yesterday, A is like the oscillator, B is the non-inverting buffer. That then goes through this variable potentiometer here, preset, and this 1U comes out, just move me, comes out, blah. So we've got our wires going up to there. We've got 200 millivolts across this 100 ohm resistor. Then if we move our lead here of our, where do you call it, meter, put it back onto DC and point it there, we should have a reading of 2 volts. That's our GM reading. So we had 200 millivolts, depending on what resistors you got in there, it does cover it in the in all the blurb, then we should have a reading of 2 volts. So then if So let's just go up there and just check our reading here. Right, 202. Put it on DC. Yeah, just wants turning down, and to adjust our GM gain, in other words the voltage as seen by the meter, we adjust this pot here, which is RB6. In my case a 20k. Oh, I'm going the wrong way. Oops. No, I've gone too far. One moment. Very sensitive. There, it'll do there. So we've got 202 millivolts, 2 volts there. That'll do. As near as, damn it. I don't want to, you know, produce a I mean, yes, I know it should be calibrated and all that, but as long as it's about there, that's not that far out. So where do we go from here? Essentially that's all our calibration process is completed, or is it? Because I've got no oscillator going into that 100 ohm resistor and it's still reading 2 volts, which makes no sense whatsoever. Let me just short those out. Yeah, I've shorted that 100 ohm resistor out. Well, that makes no sense whatsoever. Just take that off there. Does that make any difference? Okay. Right, this needs investigating. Well, after a lot more mucking about and testing and all the rest of it, the board sometimes works and sometimes doesn't, which is infuriating. So I'm going to have to go back to, you know, back to step one, retest it all again. It tested fine out of the valve tester. With it connected to the valve tester, it doesn't work. So I must be missing something, and it isn't as if I'm just sort of winging it. I've studied lots of valve testers, how they do it. It's a little bit hard to transfer this sort of method to a lot of the classic valve testers like Hickox, Avos and all the rest of it, because whereas we use in this supply, we're using variable DC adjustable power supplies. A lot of the Avos and all the rest of it use AC sort of use AC volts. It just depends, you know, like taps off a transformer, and they test volts in different ways, and sometimes they are testing the testing for GM using a bridge method, whereby you got like, it's a bit like a wine bridge, it's a bit like scales, so you're trying to null it out and all the rest of it to take a reading. It's like a wine bridge, similar to that, and so that doesn't transfer across to what we have here. So like I say, I'm missing something, and yeah, I'm getting nowhere, and I've spent most of the week on this messing about and getting nowhere fast. So I think it's time to call a break here and knock this on the head for a while. Lots more interesting things to do for the moment, and with that I'll wrap up this video. Sorry it didn't have a discernible and good result. It's just how it goes sometimes, I'm afraid. It doesn't, you know, one morning I woke up and we lived happily ever after sort of thing. That's just how it is. So with that, I shall shut up waffling, bid you adieu. Thank you very much for dropping by and watching. Take care of yourselves. Ta-da for now.